Alright, hello, I am going to be doing CSCS. I'm gonna be doing as many props as I can. I'm mostly gonna be using C++. I'm gonna make a new C++ file. I'm gonna save my file. I'm gonna make my template and we can start doing stuff. Alright, cool. Okay, I guess we'll start. So this is the Collatz algorithm. This is essentially just if the number is odd, then the number is equal to 3 times that number plus 1. Otherwise, it is equal to that number divided by 2. And it can't be proved. So to do this, we read in our input. Let's say we had number 3, and we'd say 3 goes to 10. 10 is odd, so you divide by 5, but then 5 goes to 16. 16 is odd, so you divide by 2 is 8. But then we divide this by 2, which is 4. This by 2, which is 2. And we divide this by 2, which is 1. So once this reaches a power of 2, like 2 to the third, or like 2 to the 16 or something, then it can start decreasing. And essentially that's how it's always going to end. Anyways, enough of that. So here's what we're going to do our algorithm. We take in a and then we first we print out a, and then while a is not equal to 1, we can say if a is even, a is equal to 3 times a plus 1. Otherwise, a is divided by 2, and then we can just print out this and then a. And eventually, it will actually work. We can test this, but I'm just gonna submit it.
I can't get you out of my mind. It's like I feel it for the first time. Been thinking about you all night. I've been searching for this all my life. You're just my type. I've been looking for a boy who can treat me right. Your dark hair with those eyes so bright. They look into my soul and it sparks my life. Can I take you there? Like it was the first time. Do you remember? Can I take you there? Back to when we felt like this was forever. Can I take you there?
So basically,
like it was the first time. Do you remember? Can I take you there?
If we sum up all these numbers, it's actually a formula for this, which is n times x plus 1 right here. So to find the missing number, all we do is just take the whole sum of all these numbers, then subtract them by this number. So if we subtract 4, it's 0 left. So if we have a new sum, which is 6 plus 5, and then we say the sum is 15, so we subtract 1, and it's going to be equal to 4.
I've been searching for this all my life. You're just my type. I've been looking for a boy who can treat me right. Your dark hair with those eyes so bright. They look into my soul and it sparks my life. Can I take you there?
Now we have to calculate the sums.
Like it was the first time. Do you remember? Can I take you there?
Now
Back to when we
we just need
felt
to
like this
check
was
for the sum.
forever. Can I take you there? Like it was the first time. Do you remember? Can I take you there? You're all I need. Can I take you there? take you there.
Okay, next problem. Repetitions. So we have to find the longest sequence. So here's what we're gonna do. We have a string of a bunch of stuff. So like we have we have, let's say we have A, B, C, C, B, A, like this, right? We can say that we keep track of the last sum. So first of all, we have our original. Let's call this S, which is equal to 1, and S is going to be the amount of times we repeat. So we keep a last, which is going to be L, so L is equal to A. So next time we see B, we're like, okay. Oh, we have a temp variable too. Temp is equal to 0. So whenever we encounter a letter, if the letter has already been encountered, then we just have it as, we just increase T. And then we set L to A. So then we see B, and we say this is not the same. So then we say that T gets resetted back to 1. S is equal to the max of 1 and 1, which is 1. And then the last is equal to B. If we do this for C, we can do the same thing. So temp is equal to 0, or we add 1 to temp, and then this will be equal to 0, and S is still equal to 1. But we have another C, and we say we can increase temp. So then when we say we have B, we can say, when we set our last to B again, we can say that S is equal to the max of 1 and 2. And since S, the max of 1 and 2 is 2, then we can say our answer is 2. And that's how many repeating things we have. So to do this, we just to be, we're taking the string, and then we say, we check, we have a couple of things, so we have to keep track of our counter. Plus 1, and we say our temp variable T is equal to 1 as well. Then we have char last is equal to 0. And then we go we go through the whole string. We say if S of R is equal to last, we can just increase temp. Otherwise, we have to reset temp. So we can say temp is equal to 0. Then we say last is equal to S. Finally, we have to set this so we can say count is equal to last. How we can get
Here we go again. Time is up and I'm calling up my friends. Ain't no wonder why, ain't no wonder I too. Here we go again. Call me up and you wanna be my friend. I'm the one you ride, I'm the one you ride to. If you don't wanna change, ain't no place to hide, ain't no one to run to. If you don't wanna change, I can help you out, I can help you out, I can help you out.
It should be the same, but whatever.
I can help you out, 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 I can help you out.
G-G-G-A-T-T-T.
Look, if you don't
Oh, I forgot, that's why.
wanna
It sets it back to
change,
1. I was like,
ain't no place to hide, ain't no one to run to. If you don't wanna change, I can help you out, I can help you out, I can help you out,
except for here.
I can help you out, I can help you out, I can help you out.
So, or essentially just going to take in every single element. It's like, let's say we have 3 elements right here. So we have 3 elements, which is going to be 6, 4, and 2. So we want to make every single thing as large as the last element. So what we can do is that we can set each element to the previous element that's greater than it. So we can say that 4 is going to be, we increase this by 2, and then this becomes 6, and we increase this by 2. Oh, sorry, we increase this by 4, so we get 6, 6, 6. And that's essentially how our algorithm is going to work. So all you have to do is just check whenever we have a change, whenever a variable, like whenever an array is less than the other array, then we increase our value and we change the value in the array. So then we have our then we check. So if v of I is less than the last one, then what we want to do is that we want to say ans plus equals the absolute value of the difference between them. And then we can say v of I is equal to v on minus 1. Like this. And that should work. Okay, next problem. We have an array that's beautiful. If the difference is 1. So basically we'll have a bunch of values and we'll say we make sure that distance between them is 1. So one solution we can do is that we can say we can put these in increasing order, but from the evens to odd, because if you have 1, 3, and then we have 2, 4, this is going to have a distance of 1, and so the distance is 1, and we can't have that. So instead, we'll just set the maximum. So it's going to be 2, 4, then 1, 3. This won't occur if we have like 1, 3, 5, 2, 4. So it's only for this specific test case. Well, of course, for this test case, we could also have the right answer would be 4, 1, 3, 2. Or that would not work, what I'm saying. Okay, that's the only solution for that test case. So then we can just print these out in increasing order from evens to odd. Alright, I'm assuming we take an integer. Okay. So first of all, if n is equal to 1, then our answer is just going to be 1. Otherwise, if n is less than 4, then we know it's impossible. Just because of cross-elimination. And then finally, if n is passed, then we can just do this equals 2 I is less than equal to n. CLI in space. And then we can do for the odds. Like this. So that should work. Okay, that should work. Number spiral. Let's start with numbers. So the first 5 letters of the spiral. Okay. Take it. Essentially, we have to figure out which area we have to use. So I've actually done this problem. The answer and then you multiply the number to the -1, and then we add x minus y, and you multiply this by x equals y, I think. I think that's it. Let me switch it up on the for sure. Yeah. Yes, the -1 to the and then we add square root minus y plus y. If you didn't know, I'm using Notepad++, and it's at 14. I wonder if there's no chat, so I'll just check the chat real quick. Right, I got my other laptop. So let's see. Okay, let's see if anyone's here. Doesn't look like anyone's here, so I guess that's okay. Yeah. Okay. I'll check the chat probably like 30 minutes. So, it's equal to the max of A and B, and then just it's equal to the max plus what? No, it's not max. It's A minus B times -1 to the max. A minus B times make this a long. We're gonna make this A times -1 to the mx, and it's gonna be plus mx times mx plus minus mx plus 1. I think that's it. But since it ends big, I think the order is. So we have like 3. We have 3 board. The number of ways to place hinge. So you can place 1 here. That means you can either place 1 here or here. Okay, that's it. For here, you can have
but mankind won't
this
be
and this.
destroyed.
Here we have 28
You
possibilities.
and I are working here to save.
So, I think the solution is 4 corners. Okay, so take the 3 squared, and then you multiply by 3 squared minus 1. And then add 4 times. You have 4 possibilities. 4 times. 3 minus 1 times 2, which is 1 times 2 times 4, which is easy to say. So it's taking 3 squared times 8 minus plus 8. No. 9 times 3 squared minus. Oh, okay. Times 8 divided by 2. Let's see, it's 3 squared times 3 squared plus 1. No, minus 1, minus 1. Divided by 2 plus. No, it's not plus. It's you subtract. You subtract 8. So if you divide by 2, you're gonna get 36. And when you subtract 8, you're gonna get 28. So that's the solution. Okay, cool. Okay. So equal to n equals plus. Now we can just have a solution. So answer is equal to I times I times I minus 1 divided by 2, I think. Subtracted by 4 times I minus 2 times I minus 1, and then just see how it ends. I think that should work. Alright, didn't work. 2 sets. Divide the numbers 1, 2 to n. So 2 sets that equals 1. The only input line contains an integer and print. Yes, it did. Okay. So you're trying to divide the triangle number into 2 sets equals 1. So let me think of this. So essentially, let's say you have up to 1. Let's start slow. So you have 1, 2, 3. Right? The most obvious sorting would be to put 2 and 3 together. But you couldn't have 1 and 2, and you couldn't have 1, 2, 3, 4, 5. So that means that whenever you have something that's mod, when you mod 4, it's going to be equal to 2 or 3. You get right, or 1 or 2 or something. So let's see. You have 6, 21, which is 15, which is 21. And then you have that's still when you add 7, it's 28. So automatically, if it's 2 mod 4, or if it's 1 mod 4, then it's impossible. Or if n times n plus 1 divided by 2 is even, then it's possible. I'm pretty sure I can prove this by, because we have all range of numbers, right? So let's 28. You divide this into 2, which is 14. So it's 28. You have 7, and then you have a whole range of numbers to pick 7 from. And since 7 can be picked up with 1, 2, 3, 4, 5. And since 7 can be picked up with 6, 5 or 2, the remaining is automatically just going to be 14 by process of elimination. So 1 plus 3, which is 4. 4 plus 4 plus 6 is 7. Is 8 plus 6, which is 14. So that's always going to work, I think. If you had 1, 2, 3, first you group off 3, and then you see that the 6 divided by 3, sorry, by 2 is 3. And since this has no other room, you just push back all these other ones. So essentially, we can just insert these into a set, and then check for each answer. So first of all, if n times n plus 1 divided by 2 mod 2 or is even like this, then we can just see out no solution, or impossible. I think that's what they wanted us to do. Impossible. No, it's no. You see out no. You can just see out no. And this takes one time. Next we if otherwise it's always going to be true, and then we can say answer is equal to n times n plus 1 divided by 2 times divided by 2, which is going to be divided by 4. And then we can say first list, and then second, and then we can have a set, keep track of all the variables. Alright, so let's do this. We have for int I equals n, I is greater than equal to 1, I minus minus. If ands minus, sorry, if I is less than equal to ands, then automatically ands minus equals I. Next we gotta put this in the first set. So that in place spec I, and then we have to put this in the set. So insert I, and then we just go through all the numbers. Equals 1, I is less than equal to n, plus. If it's not in the set, lag. So if dot st counts I, then you can push this back to the second set. So set that push back. Right, I'm gonna take a small break. I'll be right back. First of all, we have to put on this taking words. Line, and then we say like oh yes, we the see out to the size. So first upstairs, line, and then we see out for every element. First, like this, new line, and then now we see the second dot size, for auto S and S sec CHS. Oh, then just a new line, and that should be our program. Okay, let me see if I got this right. So ans minus equals I plus plus. Okay, this looks fine. I am going to submit. It's easy to make a lot of mistakes like that. Heavy grading. Right, it works. Looks fine. Oh, okay. Okay, I see. This is just binary exponentiation. Well, I'm just gonna do this in O of n time because I can and I want to flex. So, okay. So while n minus minus, we say ans times equals 2, ans mod equals, oh, I forgot about mod. Equals 29 plus 7. Mod equals mod. And then see how it ends. It's gonna take a long time to grade, but I don't really care. Login time is for noobs. I mean, it's for shoots. Oh, it's not a long time to grade at all. Looks fun. Number 4. Oh, yeah, okay. This is just, so if you have like a number, so a really cool trick. If you have a number and you want to find out for that number how many zeros you have to
I guess you're back.
essentially just a count of 5 and 2.
Are you gonna tell me where you went?
So we have
All the
20,
messages I sent with no
and
reply.
the result
It's like that.
will be 4, and then you add.
You're just gonna walk into my room.
This
I
becomes
hate how you assume
and then
I'll take
because 4
pleasure
divided
in
by
the
5 is
pain.
0.
The sorrows in your
So
brain.
let's if we have 100,
Cause I know you're
divide by
on
5,
the
and
run.
add 20.
I'll take pleasure in the pain.
20.
Your secrets to my
5
grave.
becomes 4. Yeah, 4.
Cause you are the only
And then
one.
this becomes 24. Then
Cause you
this
are
is 2
the
small.
only one.
This is works in about 5 times. So this is really fast.
Cause you are the only one.
If you think about it, there are 4 20s in 120. There's like 20, 40, 60, and then there's like 5 and 2s, which are composed of 10. But because they skipped 0 and 5, it's essentially just 19 plus 5. So, let me do this. It's 0. Well, and the 5 is plus 7. That's what it is. 0. Or bring it equal to 0. And it's plus equals 5. So this keeps the line with 5. And now we can just see ants. Very neat trick to know. Chili.
There will always be a place for you by my side, day or night. You know that it's killing me. Why do you always leave? It's not right. We don't fight, but I know what you've been through.
Works. Cool. Very cool.
I'll take the pleasure and the pain. The sorrows in your brain.
Is it just 2 centimeters?
Cause I know you're on the run. I'll take the pleasure and the pain. Your secrets to my grave. Cause you are the only one.
So, if you didn't know, set to this by nature. So, you can essentially just make a set. just insert it, then it's just gonna take n login time, so you don't even need to check if it's in there. Okay. So so now we can just go through settings. So for just like, it doesn't really matter. You can just, for every single value in v slot insert v, and then we can just see out the SSIs. So this takes a lot of memory, but overall it should work. Login time is very good for 2e5. If you want, you can use an unordered set, and it's possible we could do this much faster. But for this problem, it's fine by itself. The maximum running time is a fifth of a second, so it's not too bad. And applicants and M3 apartments, your task is to distribute the apartments on any free apartment. Okay. So it's just pairing. Sort both of these. What's 5 again? 5 is the maximum size. So you just have 2 pointers, one for the top and one for the bottom, and we increase. So like if we have this array x and y, we can just increase these every single time we go along. If it's less than, we increase the left one, etc., etc. How am I doing? Okay, let's do this. So okay, now we can just sort first of them. Dots begin, end, and then sort first, second dot begin, second dot end, and now we just have 2 pointers, so we can say L, R, and we keep track of these. So well L is less than So while L is less than